Okay, so everybody have that written down? Can I go ahead and do an example? Ready, Freddie? All right. Okay, so here is my first example. I'll give you a second. I don't know if you need to write down the entire problem, but maybe just like little pieces that are important. Okay, so step one is simply to read the problem. Okay, so we have an open top box, and it's important for you to realize that it's an open top. Okay, so you're not including the top of the box. And it's made by cutting small congruent squares from the corners of a 12 by 12 sheet of tin and bending the sides up. How large should the squares cut from the corners be to make the box hold as much as possible? Okay, so I'm going to start with information that is given. We have a 12 by 12 sheet of tin. And we're going to cut some corners and fold them up, and we're trying to make the box hold as much as possible. Okay, so for me to draw a picture, I have a 12 by 12 piece of tin. Okay, so 12 by 12. Thank you. And I'm going to cut little corners, and each of these are going to be an X by X. So they're squares here. And if I cut those out, and then fold along the sides, it's going to create a box. So this is the box that it's going to create. Okay, so do you understand the scenario here? Does it make sense to you? Okay, what are we trying to do? Are we trying to maximize, minimize? What are we trying to do? Maximize a what? Box. Okay, so for maximizing how much a box holds, what are we talking about? Volume. Okay, so we're talking about a volume of a box. Okay, so what we have to do is figure out the volume of this box. Okay, so hopefully you know that the volume of a box is found by doing the base times the width times the height. Okay, so first I have to figure out what this base length is. Okay, so you see this base length right here? So this base length is equivalent to this length right here that exists between those two dotted lines. Okay, so can you tell me what the length of this blue line is if the entire line is a length of 12 and we're cutting out two chunks of x? 12 minus 2x. Very good. Is everybody okay with that? Okay, so we have a length of 12 and we're cutting out two of the x's. Okay, so let's talk about the width. The width of this box is going to be the same as this length right here, that side. So what's the width of this box going to be? 12 minus 2x. Okay, and then what's the height of the box going to be? Good, by x. Okay, so the volume of our box is going to be x times 12 minus 2x times 12 minus 2x, or one might say 12 minus 2x squared. Okay, so once I have my equation, I'm now going to maximize or minimize it. So how do I find maxes and mins of a given function? What do I have to do? Good, I have to take the derivative. So now I want to take this function and I want to derive it. Okay, now looking at this, it's not in a form that we can derive. So before I derive it, what I'm going to do is I'm going to FOIL this sucker out, put it into standard form, and then I can just do basic differentiation. Okay. So what I'm going to do first is I'll FOIL these two. So 12 times 12 is 144. 12 times negative 2x is negative 24. X, and negative 2x times 12 is negative 24x. And negative 2x times negative 2x is positive 4x squared. So if I combine like terms, that's simply 144 minus 48x plus 4x squared. And the last thing that I'm going to do here is simply distribute that x through. I'm going to go ahead and put this in order from biggest to smallest for my exponents. So I'm going to say that this is 4x cubed minus 48x squared plus 144x. All right. So there's my volume equation in standard form. So now I'm going to do what? Good. Take the derivative. So what is the derivative of that function? 12x squared minus 96x plus 144. All right. So now, in order to find critical values, what do? Good. I'm going to set it equal to 0. I noticed that this can be factored. I can pull a greatest common factor out. What's the greatest common factor there?
12.
12. Good. So if I pull 12, 96 divided by 12 is 8. And 144 divided by 12 is 12. Okay, so what happens with that 12 out in front there? Goes away. So I can use easy method to finish this. What two numbers multiply to 12 and add to negative 8? Good, negative 6 and negative 2. So I end up with two critical values, one being 6, the other being 2. So how am I going to decide if it's a max or a min? Good, I'm going to do a number line test. Exactly what we've been doing. So we got 2, we got 6. I'm going to plug it into my first derivative fully simplified. We can use the one where the 12 is gone since it's a positive value. It won't change the positive or negativity-ness. Okay, so if I plug in a value less than 2, such as 0, would I get a positive or a negative? Positive, good. And if I plug a value such as between 2 and 4, so 3 would work. If I plug 3 in, I would get negative times a positive, right? Which makes a negative. And if I plug, let's say, 7 in, would I get a positive or a negative?
Positive.
There we go, positive. All right, so this goes up, goes down, goes up. So this function has a max and a min. Which one are we looking for again?
Max.
A max, so you need a max at the x value of 2. Okay, now the next thing I need to do is just make sure, what is the question asking me to find? Am I trying to find the dimensions of this box? What are they asking? So it says, how large should the squares cut from the corners be? So what is the answer that I'm looking for? Okay, so those are just the lengths of the x's. So the squares are just going to be 2 by 2. Yeah, good. And we're talking in inches, so I want to make sure to label that correctly. 2 by 2.
I'm confused. What is it asking?
They're asking us to, so it says, how large must the squares be to make the box hold as much as possible?
Well, don't cut squares.
What's that?
Don't cut squares.
As much as possible,
Okay, the box, and here's a box, like a cube squares,
right?
and it's cost.
Well, it starts with a flat, like 12 by 12 sheet of tin. So it's like, here's your box right here. And we're gonna cut little squares. How big is the squares to max? Oh. Not yet, we're just trying to make a box. Does that make sense? Okay, you ready for another one?
Wait, so what did you do after you found the critical number?
After I found the critical numbers, I used a number line test to figure out which one was the max and which one was the min.
Well, after you found the max,
After I found it, then I just made sure that I was answering the question that they're asking me. So it says, how large should the squares be? They could have asked me what are the dimensions of the box, and then I would have had to figure out what the dimensions of the box would have had been. So I just had to make sure I was answering the question.
Okay.
Try one more. There we go. There's another one. Okay. So clearly we're looking for a minimization of a perimeter. Okay, and it says, what is the smallest perimeter possible for a rectangle whose area is 16 inches squared? So we're asked to find the dimensions of this rectangle. Okay, so we can start by drawing a picture. So we're working with a rectangle who has an area of 16 inches squared. Okay, so here is some rectangle. I don't know what the dimensions of the rectangle are. All I know is that it has a area of 16 inches. So if we're talking about an area, how do you find an area of a rectangle? Okay, so let's label these as some length and some width. Okay, what is the thing that they're asking us to minimize? The perimeter. So we have to know that we are trying to minimize the perimeter. That's the piece that we are going to derive. Okay, so what is the perimeter for a rectangle? Let's slide this over. Perimeter would be 2 L's plus 2 W's, right?
Oh.
Okay, so I have the equation that I want, but if I was going to derive this right now, I have two variables that are in terms of my perimeter, and that's a problem. I can only derive a function that is in terms of one variable. So what I'm going to do is I'm going to go back to my area equation, set it up, and I'm going to solve for one of those variables, and then I can do a substitution into my perimeter equation. Okay, so what is the equation for my area from that box? 16 is equal to what? Length times width. Okay, now I can choose which variable you'd like to pick. Do you want to solve for the L or do you want to choose for the W? What did you say? For the W? Okay, so if I solve for the W, we would just divide by the L, right? Okay, so now I'm going to go into the red equation and replace the W with a 16 over L. Okay, so now I have an equation of a perimeter that is only in terms of one variable, which in our case happens to be the length. Okay, before I derive this, I'm going to rewrite my second term so that it's in a basic form for me to derive. I have 2 times 16 over L. How can I rewrite that so it's easy to derive?
32 over L.
32 over L. What about pulling the L up? If I pull the L up, what is my exponent?
-1.
To the -1, good. So there's my perimeter equation. So if I'm going to find the minimum of that equation, what do? Derive. Step 1, derive. So what's the derivative of that? 32L to the -2nd, right? Okay, and then what do I do?
And then you write it.
Okay, set it equaling to 0. I'm going to rewrite it so that my L goes downstairs. That'll be easier to solve. Okay, how would you solve that equation?
You subtract 0.
Okay. Okay, then what would you do? What'd you say? How do you get rid of the L in the bottom?
You
We gotta send
multiply
it
it
out.
out.
Right, we multiply it out. So we're gonna multiply the L squared out. So we're gonna have negative 2 L squared equals negative 32. Okay, then what? Divide by negative 2. So what's 32 divided by negative 2? Well, that was nice. And the square root of 16 makes 4. Now technically if I'm solving an equation I should have a plus or minus, but do I need the minus part?
No,
Why not?
because it's not a thing.
Okay,
You can't have a
right.
negative length.
Right, exactly. I cannot have a negative length. Okay, so I found my L for... Oh, do I need to do a number line test?
No,
Why not?
because it's messed up.
I know. Why do I know it's a minimum? Kinda. We're looking for a minimum, but what else? We only got one critical number, right? So I know that the critical number is either a max or a min, and if they're asking me specifically for a minimum, it's going to pop out as a minimum. Okay, so it might be smart to double check and verify that it is in fact a minimum, but probably they're not going to ask for a maximum when you can only find a minimum, right? So the question says, what are the dimensions of this rectangle? I know that the length is 4. How am I going to find the width of this? Plug it into this one, right? So if my length is 4, then I cannot write W. W is going to be 16 divided by 4, which makes 4. So we got a 4, and we're working in inches. 4 by 4 rectangle, or one might call that a square. Interesting. Do we have questions over there, Jackson?
Yeah,
Sure?
it's not. Wait.
It's okay to ask questions. We've established.
Wait, is a rectangle a square? A square is not a rectangle.
Fourth grade.
A square is a rectangle, but a rectangle is not a square, because a square by definition
Well, then
has to
you
be.
can't have it.
Well,
Yeah, that's.
Well, that's a square is a rectangle, so we're okay.
But you're trying to buy this square.
You can't get like.
Yeah, there you go. If it would have said find a square, and we came out with a rectangle, then that would be a problem.
Ghostbuster.
All right, you got one more in you?
No, worksheet.
Can we do some
The worksheet is one like this. There's a couple problems that are like this.
Can we do some there we go.
I agree with whatever.
We can do that. Let's do this one first, and then we'll do a worksheet problem. They'll let you pick. Okay.
That's your real name.
No. Fake. If I told you my real name, then I could kill you.
All right, so we got this rectangle that happens to be inscribed in an isosceles right triangle whose hypotenuse has a length of 2 units. Someday it's going to happen, and you're going to be like, oh, man.
Oh, I know how to find a rectangle inside an isosceles
I have to write all that down.
Well, you have a rectangle inscribed in a isosceles right triangle with a hypotenuse of 2.
So I have to write all that.
Or you could just draw a picture. I mean, it's up to
I don't know
you.
how to draw the picture. Where are all these numbers on it? I don't know what these numbers are.
There's not homework, is there?
Oh, yeah. Oh. 6, I think. No, 8. No, it's not too bad. Yeah. Okay, are we done?
No, I don't get it.
What do you mean you don't get? I just copy.
What
I'm
is
getting
those
it.
numbers? What's the 0 and the 1? Wait, is that you?
Okay, so this is a coordinate grid. So you got an x-axis and you got a y-axis. See right here, this is the point 0, 0 right there. Okay, so the hypotenuse of the big triangle has a length of 2, which means that this line right here intersects the x-axis exactly at 1, 0. And this line over here intersects exactly at negative 1, 0. Okay, so if we have a isosceles triangle, what do we know about the length of this side and the length of this side?
They're the same.
They're the same. And if you cut that in half, what happens when you cut an isosceles triangle in half right there?
It makes 2 triangles.
It makes another what kind of triangle? Another isosceles triangle. Okay, so if this is an isosceles triangle with a length of 1, what's this height length? It's a height of 1. Okay, so this B, you disagree?
It's a right triangle.
Yeah, it's a right triangle. Cut a right triangle in half, you cut 90 in half, it makes 90 degrees. Okay, so would you agree that this B point is exactly at the point 0, 1? Would you agree?
Yeah.
Okay. All right, question A says, express the y-coordinate of P in terms of x. So all we're really doing here is what is the equation of the line AB? You see this line right here in red that I just drew? How do you come up with an equation of a linear line?
Y equals mx plus b.
Okay, so we have y equals mx plus b.
A b is a 1.
B is 1 because it's the y-intercept.
M
What's
is
my
negative
m?
1.
Oh, there you go. So the equation is negative x plus 1. That was a bad one. Plus 1. Everybody follow that? Y-intercept of 1, the slope goes down 1 and to the right 1, making a slope of negative 1. What's that? Because the equation is mx, so negative 1 times x, making just negative x. Okay, now question B says we are going to express the area of the rectangle in terms of x. Okay, so you see this blue rectangle. You see the blue rectangle? Yeah. How do you find the area of a rectangle? The length times the width, right? Okay, so tell me, if this rectangle intersects this line at the point xy, let's call that point xy. Okay. What is the base length of this rectangle? What is the distance from the origin to this side? X. It's a length of x. So the length from the origin to this side length, the end of the base. So it's a length of x. So what is the full length of the entire base?
2x.
1.
2x. Okay. So my area is 2x times my y, right? So what's my height of this rectangle? What's the height? Y. What is y equal to? Negative x plus 1.
Oh.
Negative x plus 1. Okay, so that's the area of the rectangle. So now question C says, what is the largest area the rectangle can have? So what are we going to do if we have an area? We're going to derive it and set it equal to 0. So before I derive this, I look at this and I could do a product rule. That would be fine. Or I could distribute the 2x through and just do basic. What would you prefer? Basic. So we can say the area is equivalent to negative 2x squared plus 2x, right? So if I derive that, what's the derivative of that? Negative 4x plus 2. Okay, then what do I do? Okay, set it equal to 0, yeah. Subtract 2. Divide by 4. Can I jump to what we get?
I don't even get A. Yeah, I don't get any of this.
How I got A? How I got A? The red, the equation of the straight line. Do you remember that the equation of a straight line is y equals mx plus b? Yes, no?
I don't remember that, but I know it now.
You don't remember that? That's unfortunate. So the m is just the slope and the b is the y-intercept. So you can see in the y-intercept is the b value of 1, goes up 1. And the slope is rise over run, so it goes down 1 over 1. So negative 1 over 1 makes negative 1.
But it's like, how do I know that's what it's asking? This is the line.
Because it says hint. Hint. Equation for the line AB.
Oh, I didn't like that.
So we good then? Okay, so did I answer the question?
And then area, why do you put the equations about? Why did you get B?
Because the area of the rectangle is length times height, right? Okay, so the length of that is going to be 2x's times the height, which is your y height. So the height of y, instead of writing 2x times y, because then I would have two variables, I'm going to rewrite y as what I just found it to be in question A. Y is...
So why do we use rectangle?
What?
Why do we use rectangle?
Because that's what they asked us to find. They drew the picture. We're just doing what they said. So, anybody want to tell me what the dimensions of this rectangle is? Okay, so if my x length, let's finish this. Okay, if my x length is 1/2, right? 1/2. Okay, what is this whole base going to be? 1, right? So I have 1. How do I find the height?
I told you the base is 1.
Plug it in. So if I plug that in, what's negative 1/2 plus 1? 1/2. So this is going to be a 1 by 1/2 rectangle. What's that? You ready for the test now?
Well, I'm going to be gone Friday, so it's not.
You probably are.
Just the add here. Hey, I'm just
And if you guys want, we can do the problem together. Otherwise,
No.
Yeah, let's do
Which one the hardest one to do? You might have to write small.